So when we say an x power n plus an minus 1 x to power n minus 1 plus an minus 2 x to power n minus 2 dot 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 a1x plus a naught is equal to 0. I'm again going to remind you that in this syllabus we are going to study this. We'll say that a0, a1, a2, an, all these coefficients are constant real numbers. For us, these are real numbers. Okay, these constants are real numbers. We don't consider them as complex number. They may be complex numbers, but we say they are real numbers. Okay.
Okay, sir.
And that's why we say this is a real polynomial. We say this is a real polynomial. Any alpha,
yes,
this satisfies this polynomial such that an alpha to power n plus an minus 1 alpha to power n minus 1 a1 alpha plus a0 is equal to 0, then this alpha is known as a root of the polynomial or zeros of the polynomial. So all those values of x which satisfy this equation equal to 0 are known as roots. And for an n degree equation, this is an nth degree equation. For nth degree equation, we will have n roots. Okay, those roots.
yes, sir.
If I call those n roots like alpha 1, alpha 2, alpha 3, alpha n, those roots can be real as well as complex. We are not worried about that because complex roots is a part of our syllabus. Right now, we are not studying complex roots, but complex roots are our part of our syllabus. But remember, a0, a1, a2, a3, an, these constants, they cannot be complex numbers. They are real numbers.
Okay, sir.
So I'll just take a simple example now. Now, if I take a second degree equation, that is ax square plus bx plus c is equal to 0. This is a second degree equation, and this is
Yes,
known
sir.
as quadratic equation. This is known as quadratic equation. Do you know how to solve a quadratic equation?
We have to factorize it, right?
Okay, you know how to factorize it. Okay, so we'll discuss that
Yes,
method first. So if I give a simple equation like x square minus 5x plus 6 is equal to 0, then what we do is we multiply the coefficient of x square with this constant. So this is 1 into 6. This will come out to be 6. And then what we do is we do this middle term splitting plus 5 such that the sum comes out to be minus 5 and the product comes out to be 6. So when you do the factors of 6, so there are 2 and 3 are the two factors of 6. So the factorization becomes easy. We can say this is minus 2 and minus 3. Minus 2 minus 3 gives minus 5, and minus 2 multiplied by minus 3 will give us plus 6.
Plus
So
4.
we can write this equation as x square minus 2x minus 3x plus 6 is equal to 0. Remember, minus 2x multiplied by minus 3x will give you plus 6, and minus 2x minus 3 is minus 5x. So now we take common here, x is common, x minus 2, and from here we get minus 3 common, x minus 2. So again we take x minus 2 common from here. So I take x minus 2 common, so x minus 3, and this is equal to 0. Okay, now if we say that multiplication of two number is 0, what does this mean? If x minus 2 multiplied by x minus 3 is 0, it implies either x minus 2 is equal to 0 or
x minus 3.
X minus 3 is equal to 0. So if x minus 2 is equal to 0, that means x is equal to 2. And if x minus 3 is equal to 0, that means x is equal to 3.
Yes, sir.
So basically we get the two roots of the equation, which are 2 and 3. So if I take this x square minus 5x plus 6, if you put x into 2, what will happen? 2 square minus 5 into 2 plus 6, which is 4 minus 10 plus 6, which is equal to 0. So when we put x into 2 in this polynomial expression, this becomes 0. So he said 2 is a 0 in this equation of this polynomial. Similarly, if I put x into 3, it is 3 square
3 is
minus
also
5 into 3 plus 6, which is again 9 minus 15
0
plus 6, which
plus.
is again equal to 0. So we say 3 is also the 0 of this equation.
Yes, sir.
Okay. So this is one way of solving a quadratic equation. This is known as middle term splitting. If you observe this, x square minus 5x plus 6 is equal to 0. If you observe, the roots of the equation was 2 and 3. The sum of the root was
Yeah.
s is equal to
5.
plus 3, which is 5, and here it is minus 5. And the product of the root was 2 into 3, which is 6, where here it is plus 6.
Oh,
Okay.
yes, sir.
So if a is 1, so if I'm saying that here the a was 1 actually, here this was 1. Otherwise, we can say that if this is a question ax square plus bx plus c is equal to 0, then it says the sum of the roots are 2 and 3, which we call it as alpha and beta. Okay, if we call it alpha and beta, then the sum of the root is alpha plus beta, which is minus b by a. You see here 2 plus 3 is equal to 5, which is minus of minus 5 upon 1. So he says the sum of the roots is minus b by a. And the product of the root, which is alpha beta, which is c by a, which is 6. In this case, this a is 1. Okay.
Yes, sir. So, but where do we need to find the sum of the roots and product of the roots?
Many places. When you solve the equations, there may be questions, and there may be many practical applications also where you will have to find the sum of the roots and the product of the roots. It depends on the question actually.
Oh, okay.
Okay, questions will come where you learn. Or if I say, if the roots of the equation are given, if I ask you find the equation whose roots are 3 and 5,
Oh,
saying I say that find the equation whose roots are 3 and 5. Then you can simply say the root is, the equation will be x square minus sx plus p is equal to 0. So what is s? S is 3 plus 5, which is 8. What is p? 3 into 5, which is 15. So the equation whose roots are 3 and 5 will be x square minus 8x plus 15. That's all.
okay, sir.
Another way of saying it is the roots are 3 and 5. You can also write this like this: x minus 3 into x minus 5 is equal to 0. Right? For this equation, x, 3 and 5 are the roots of the equation. If I simplify this, x square minus 5x minus 3x plus 15 is equal to 0. X square minus 8x plus 15 is equal to 0. Same equation.
Yes, sir.
Okay, so why should I follow this complete complex multiplication, expanding the bracket and do all these arithmetic? I simply know this formula: x square minus sx plus p is equal to 0. If the roots of the equations are given, then you can find the equation by x square minus sx plus p is equal to 0.
Yes, sir.
Okay. So this you know before or you don't know?
Yes, sir, I knew this.
Okay, so figure out some questions and practice of this splitting of the middle term. Okay. The another way of solving the equation is making a perfect square, if possible. So let's say this is x square minus 4x plus 4 is equal to 0. This can be written as x square minus 2 into 2x plus 2 square is equal to 0. You can say a square minus 2ab plus b square is equal to 0. You can say this is x minus 2 whole square is equal to 0. Whenever
Yes, sir.
you are able to make a perfect square, because it's a quadratic equation, we should have always two roots. So we say this is x minus 2 multiplied by x minus 2 is equal to 0. We say the two roots are 2 comma 2. Or we say that it is a repeated roots. This is repeated roots. Whenever the quadratic equation can be converted into a perfect square, you'll always get a repeated root.
Okay. Yes, sir.
For example, x square minus 6x plus 9 is equal to 0 can be written as x minus 3 whole square.
So 3 is the repeating root.
The 3 is the repeated root. Okay, I am taking very simple examples where the roots are integers, but it can be fractions, it can be rational number or irrational number also. You have to practice all those questions. Okay. The last is, if the equation is something like this. Now, neither you can make it a perfect true, क्या बोलते हैं, perfect square, nor the middle term splitting works out. Then we have a quadratic formula. In general, the equation is ax square plus bx plus c is 0. If you cannot apply middle term splitting, if it's complex, difficult, or if it is not a perfect square, we say the root is given as x is equal to minus b plus minus square root of b square minus 4ac divided by 2a. This is a simple way of writing the roots of the equation. Even for this equation also we could have done this method, but then it is difficult. If we can convert it into perfect square, why should we follow this path? Okay. So for this, if I say, then the roots will be x is 2 minus b is 5 plus minus b square is 5 square minus 4, a is 1, c is 1 divided by 2a. So this is minus 5 plus minus 5, 25 minus 4 is 21 by 2. So the two roots will be minus 5 plus root of 21 by 2, comma, minus 5 minus root of 21 by 2. These are the two roots of the equation.
So what's the derivation of the formula that we got?
You can skip that for right now.
Okay.
If you want to do it, it's actually, the derivation is you have to convert this into a perfect square.
Oh.
Okay.
So this formula is only for squares.
Pardon?
This formula is only for the squares.
This formula for the quadratic equation, not a square. Quadratic equation.
Oh, any quadratic equation.
This formula is valid only for a quadratic equation because it is only giving us two roots. The two roots are minus b by 2a plus b by 2a minus b by 2a minus, sorry, square root of b. This b square minus 4ac, we also call it as d, which is known as discriminant of the equation.
Okay.
This d is known as discriminant of the equation. Okay. So you see that because it's a square root of d, this d has to be greater than 0, greater than equal to 0 for real roots. Why? Because Till now, we don't know how to find out the square root of a negative number. If b square minus 4ac is less than 0, then we'll end up finding out the square root of a negative number, which we don't know today. Okay.
Okay.
So if b square minus 4ac is less than 0, if b square minus 4ac is less than 0, then we'll end up finding out a square root of a negative number. That means the roots of the equation will be complex.
Yes, sir.
If b is less than 0, the roots of the quadratic equation will be complex.
Complex.
Right now, we have not studied complex number, so we'll not go into that domain. For us, till we learn complex number, all the quadratic equations which you solve will always have real roots. Real roots means
Yes, sir.
b will always be greater than or equal to 0.
So what exactly does the discriminant do? Like, why do we need to know it?
The discriminant tells us whether the roots are real or complex.
Okay. So for solving questions, do we need to like apply it anywhere?
Yeah, many places we just work with discriminant and try to find out many. This is starting Sanvi.
Acha,
Qualification is a very
okay.
in-depth chapter. It is like if you go for a JE level preparation, it's a 1 month lengthy chapter. It takes around 15-20 classes to complete this chapter. Okay, so this is just.
So for now, I just need to know that. Yeah. So for now, I just need to know like how it's for real numbers and complex numbers.
Yeah. Whatever I'm telling you, that is what you need to know. What I'm not telling you is right now of no use to you. As you will proceed to classes, and I will cover up whatever is required. What is taught to you in your classes, I will cover that slowly and slowly.
Okay. Yes.
I will not go ahead of your classes because I don't know what they are going to teach you in your classes. Okay, that's the reason I'm limiting myself. Okay.
Yes, sir.
I'll again come back to the simple equation which I solved by middle term splitting. X square minus 5x plus 6 is equal to 0. So what was the roots? 2 and 3. If I solve this by quadratic formula, x is equal to minus b plus minus square root of b square minus 4ac divided by 2a. This is 5 plus minus 1 by 2. So this is 6 by 2 comma 4 by 2, which is 3 comma 2. And by middle term splitting also we did the same thing. X minus 2 multiplied by x minus 3 is 0. So the roots of the equation are 2 and 3. Here also the roots of the equation are 2 and 3.
Yeah.
But if I can solve a question by middle term splitting, we should solve it by middle term splitting. Why should we use this method?
Yes, sir.
Okay. So do you know how to draw graphs?
I think you taught last class, sir, the quadrants where. So, but here the graph is given for functions and all. We have not done functions, so I wouldn't know that.
Not functions. Draw any graph like by functions.
Yes, sir. I know how to draw any graph.
Okay. So this is my x-axis. And this is a y-axis. This is my x-axis and this is a y-axis. If I ask you to the graph of y is equal to x square, how do we plot a graph? What we do is first we draw the table and we figure out the values. So we take the values of x, we find the values of y. So if x is 0, then y is 0. If x is 1, then y is 1.
Y is 1.
If x is 2, then y is 4. Okay, let me take x is -1, then y is again 1. X is -2,
Yes.
then y is 4. X is 3, y is 9. X is -3, y is 9. Okay, so this is 0, 0. Okay, then this is 1. Let's say this is 1, 1. Then this is 2, 4. Then this is 3, 9 somewhere here. Similarly, it will be here, symmetric. So if I draw the graph of y equal to x square, so
Yes, sir.
I may not be able to draw a smooth curve passing through all the points, but it will be something like this. And similarly, it will go something like this. Okay, so let me draw a free-end graph. The graph is something like this actually. Okay, here on this small.
Yes, sir.
This is actually a parabola. What is this? Parabola.
Parabola.
So the graph of a quadratic equation is always a parabola. So if I say x square is equal to 0, now this is a quadratic equation. Just a second, Simon. So x is equal to 0. This simply says x is equal to 0. And we say that at x is 0, this is becoming 0. Okay.
Yes, sir.
So now it's a homework for you. No,
Hmm.
let me plot this graph again. Y is equal to x square minus 5x plus 6. The same graph.
Okay, sir.
So if I draw this table now, if I put x is 0, if I put x is 0 here, then y will be 6. If you put x is 1, then 1 plus 6, 7 minus 5, 2. If I put x is 2, then y will be 0. If I put x is 3, then again y is 0. If you put x is 4, 16 minus 20 plus 6. So it is something. Okay, so when x is 0, y is 6. So I know the graph of this, so I'll plot this graph for you. Okay, so the graph is like this. So this is the point 2 and this is the point 3. For x equal 2 and for x equal 3, this is becoming 0. And we know that x square minus 5x plus 6 is 0 only when x is 2 and 3. So these are the two zeros of this equation, quadratic equation. So at x equal 2 and 3, this graph is becoming 0. But when x is
Yes.
0, this is 6, 0, 6. Okay. So again, this is a parabola where it's cutting the x-axis at 2 points, 2 and 3.
So those two are the roots of the
Those
polynomial.
two are the roots of this quadratic equation. So if I ask you y is equal to x square minus 8x plus 15. Okay. So what you do is you draw the graph of this equation and send me on the WhatsApp.
Okay, sir.
And y is equal to minus x square plus 8x minus 50. These are two
Okay, sir.
equations. You have to plot the graph and tell me.
Okay, sir.
Okay. This see you when you will draw the graph now, you'll find something interesting in this, the relation between these two graphs.
It'll be opposite side.
Yes, it will be opposite, and you have to relate this with here, what is here and what is here. So I'll
Yes.
give that more insight when they are opposite in tomorrow's class. Okay,
Yes.
because the class will get over right now. So I'll give more insight
Yes, sir.
why this is happening here. Okay.
So for the homework, should I just draw them both on the same graph?
You just draw the graph like I draw here. Na? You just make this table, put some values of x, find out the values of y, do a rough sketching. You don't have to be very like particular about up to the scale. The figure should just reflect that yes, you understand what is the shape of the graph.
Okay, sir.
Okay. And then we'll go and discuss in detail about the importance of ax square plus bx plus c. What about when a is positive and negative? Right. Tomorrow we'll discuss about what are the two cases when a is positive and when a is negative. And then slowly and slowly we'll go and again discuss the value when b is positive, c is positive, negative, or the combination of a, b, and c being positive or negative.
Okay, sir.
Okay. Okay, so we'll over the class here only. We'll continue tomorrow.
Yes, sir.
And please join classes or class on time so that we can give
Yes, sir. Yes.
time actually, na? Full focus time.
Yes, sir.
Okay.
Yes, sir. I'll join early tomorrow.
Okay, bye.
Thank you, sir. Bye.